Conference, your source for JVM knowledge.
But we will start talk about Kotlin and implication in an IoT project. So this is a full formal definition of what is Internet of Things. And they say to the Internet of Things of IoT is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers and the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. But in simple terms, is connect things to the internet. But something interesting about Internet of Things is that people, as usually, or the makers, forgot the part of connect things to the internet, and they only are making things. So this is the Coke machine. This was basically the first IoT project that exists and was created in the Carnegie Mellon University. And what happened with these guys in the university is that they sometimes go to the machine and the machine don't have more Cokes there. Or they go and the provider just arrived a few minutes ago after them, and the codes were not called as they wanted. So what they do is install some sensors in the machine to check if the machine have Cokes or not. And they have other sensors that have metrics about how long ago that provider was in the machine for put the code. So they can know if the machine have Cokes and the Cokes were called. So basically, this is other example that is about coffee. The programmers in an office sometimes go to the kitchen and the coffee machines don't have any more coffee, so they put a camera can control if is coffee or not. So they don't need to make this long journey from their workplace to the kitchen for don't found coffee. So now in the IoT industry, we have a lot of implementations. So now we have the smart cars, right? That they are checking things, if they can drive in the car. Something that happened with the smart car is that they are trying to detect in the good way pedestrians, so they are collecting this information, sending this information to the cloud can be processed. We have wearables. This is really interesting, for example, for athletes. Now they have wearables that can put in their clothes, and they can have metrics about the pressure, heartbeats, or temperature that they are handling, and then they can transfer that information to their cell phones and obtain statistics about their behavior, how good they are being. We have smart appliances. In this case, the first things that we have were a fridge. This thing that we will tell you when you need milk, or if you don't have more water, or if you need eggs. Then we have smart buildings. This is not the same that smart homes. For example, in smart buildings, we can have these hotels that are adding a lot of technology. We are not using anymore in some hotels these cards. Now they are connecting to your cell phone an application can open and close the door, or we are using through an application can turn off our lights or the air conditioner or the windows, right? They have these things that you can go down and up. Then we have smart homes. For example, the people that travel a lot can have cameras for control what happens in their doors or the porch, or if happens something inside the house, or is there when we have the smart lights can make automation in the house and control everything too, again, from an application. We have smart TVs too. Smart farming is other really interesting one. For example, in Guatemala, we have a lot of smart farms, how control crops, how can detect sickness in our crops in the beginning. And we have smart health. This is other interesting thing. For example, Google last year launched something that they are trying to study the eyes of people for detect some sickness for heart or diabetes. But we can indeed detect other things, and we have smart cities too. So what happened with the IoT is that we can have ideas for increase the value of our products. So I can make more efficiency processes or define when some things is working and others not. For example, in Guatemala, we have a really interesting IoT project that this guy is using for food restaurants in food courts. So they are putting cameras and are detecting in which days they have more people going to browse food than others. So they can say to the company in which days they need to have more people attending the store than other ones. So why you will have all the time 10 guys trying to provide all the things that people is going to buy, if you only will need that 3 days at a time. So you can hire people just for go these 3 days, and the other days only have 3 guys attending your customers. Or a little bit of how happiness is the people. So this is something hard to find, but they are trying to have this face recognition and define if the people really is going happy with the service or not. Or you can indeed make this work for malls. Malls are requiring for projects when we define if are women's the ones that are going to the malls, or are men if they are going with kids or not, or what is the real reason that people is going to a mall. Sometimes we go to a mall just for use the food court, or for use the bank section of the mall, but we are not really buying things in the mall. Or the mall have a supermarket inside, and the people is just going to the mall for use the supermarket. So how will you use the mall for make that you go to the mall for make nothing that you really don't need? So for that works. And we have 3 categories of IoT project. The first one is the category that only collect information and send that information to somewhere for it be processed. This is all the things that they do. We have other one that just receive information for act against that information. And here is when we have the light bulbs that we send that turn off or turn on. And then we have the other category that make both things. So they receive instruction, but they also collect and send that information. And here we have the example of handle crops. For example, I want to optimize the way that I am making the irrigation process in my crops. So why I will always stay irrigating in some hours if maybe the crop don't need water at this time. So I can put sensor for detect the amount of humidity in the air is, this is soil moisture. In the soil moisture. So if that don't have more water, I will open the irrigation process and make this happen. We in Guatemala, we have a lot of coffee crops, and the crops of coffee have a sickness that is called roya. I tried to use that, found this in English, but don't exist translation. This is a sickness especially for coffee. So usually it's a guy going to see all the coffee crops and detect if they have roya or not. But now they are trying to introduce IoT project for take images. This that happened with drones, for example. So they take the pictures of the crops and they make an analysis of the pictures for define if the crops have roya or not, and that is providing to us a fast way to action against this sickness in coffee crops. So this is an example of an entire system of IoT. So we have the part of collect data, then we have some IoT hubs or gateways that we use for make that real connection for send our information. Sometimes we don't make to these devices that collect information are the ones that connect directly to someone in the cloud for save the information. If we use put an intermediate guide for do this. But what happened is that as usual people is focused on this section, collect data for IoT projects. And in that I give this talk before, and when I say I will talk about IoT, and the people, the first thing that they say, oh, which card you will speak? You will speak about Arduino, or you will speak about Raspberry Pi? And I say I will not speak about any one of these guys, because IoT is not only about that. But in that, this becoming a fight between Arduino or Raspberry Pi. And you have some guys here saying this Arduino is better than a Raspberry Pi. And the people that say Raspberry Pi is better than Arduino. And we really cannot define which one of these is better than other because are not really interchangeable technology. Arduinos are microcontrollers and Raspberry Pi are microprocessors. And this is something that you need to take in mind when you will create IoT projects. Why? So microcontrollers basically are a small computer inside an integrated circuit. So that means that in the same circuit, I will have my CPU, I will have my ROM, my RAM, so I will have my GPU ports for interact with sensors in the same way. And I can do nothing for modify this, except that I create my own card. But if I brought one, I have restricted limited of resources. So what happened with microprocessors? Microprocessors basically is just the CPU inside this integrated circuit. In Raspberry Pi, what happened with Arduino and Raspberry Pi is that are technologies for education. So the Raspberry Pis don't include only the CPU, they also provide to us in these cards that we go browse for make a prototyping a RAM, and we have the GPIOs there, and we only need to add the room, so I choose my SD card, and depends on that is the amount of memory that I will have. But the real tool is a microprocessor is just the CPU. And this is what makes sometimes use a microprocessor more expensive than use microcontrollers. Because I am not buying just the integrated circuit, if not, I need to browse these other peripheral things that I need. The RAM, the room, the GPIOs that I will use. Other things that happen a little bit here that exists to this fight is, for example, with this technology like Raspberry Pis, I only can use digital sensors, but I cannot use analog sensors like happened with Arduino. And the other things that happen is that sometimes the GPIOs in a microprocessor are not so faster, so some sensors don't work with them, and we need to use Arduino, only technology like Arduino microcontrollers can use these sensors. So we will continue, and what happened about this other part? So how I will handle my information, how will we send this information to the cloud, or what I will do with this information. So I have a friend that is doing a lot of IoT in Guatemala, and he's trying to create a community, and he always say, I need that you came and you explain to the guys how make web services, how make front end, how make a website, how they will analyze their information, because they are good makers. They are good technicians making the hardware projects, but they don't know nothing more than that, and we need more than that. So, and what about security? Again, right? We are creating projects, and doesn't matter what happened. For example, with the light bulbs, happens that we're hacked, and then cyber guys were turning on and off the light bulbs. This is because have nothing of security. And this is something that I call beyond the things. So we have a world here far away from just make something with Arduino or something with Raspberry Pi. In that we have in the students, the famous project is they make of SIG lines that they are resolve labyrinths. So they are using sensors for detect the lines, or using ultrasonic sensors for detect walls and solve the labyrinths. And they believe that they are doing IoT. This is just exercises for learning how to do the hardware part. Well, I will skip this. What about Kotlin in all this of the IoT, right? So I was making an investigation. In the IoT industry, people don't like to use a little bit Java. And this is because Java can be a little bit heavy, so the footprint of Java is biggest for can run inside embedded devices, especially in microcontrollers. So usually Java is something that we can use in microprocessors because we have more memory. But they don't like to because they don't have a strongest knowledge about how works Java. So in Java, we have a virtual machine that runs, that is the one that runs our code. But they don't know that the virtual machine is a standard. So how many of you know which virtual machine are using when you are programming backend? You know, I know your face. You? No. Oh, okay. What are you using, the JDK of Oracle or the OpenJDK? OpenJDK. And what happens when you download the OpenJDK of the website? You have options. How do you choose which option? What say that? You go there and they say, download OpenJDK with hotspot, or download OpenJDK with J9. What fuck means this hotspot and what means this J9? Someone asked that? No, this is the name of the virtual machine that you will use. So, okay, how many of you read something, attend some talk, or see a video about GraalVM? You know where is GraalVM? They don't say no. What means VM? Virtual machine, right? Oh my God, GraalVM is a virtual machine when we can run Java code. So exists two virtual machines that are optimized for embedded devices. For example, exists a company called Azul System, and they have a virtual machine called Zulu that are precisely optimized for embedded devices. So I can use Zulu for run Java code inside IoT projects. And also, in Java 8, Oracle make a lot of bit of efforts for make Java compatible with IoT projects, and we have compact profiles. So I can reduce the amount of libraries of the Java Standard Edition API just for the ones that I need. So I can use create a smallest runtime environment based on these compact profiles. So if I am not using, for example, Kotlin native, if I am using the Kotlin compatible with Java that is interoperability, I will need to run this Kotlin over a Java virtual machine. So the people don't like to use it. But we can use Kotlin native, but in that Kotlin native is not designed for make IoT projects. If we want to use Kotlin, we need to do something similar with Java that have the Java native interface for connect with code in native code, that is C code. So we need to use some C libraries for connect with the GPIOs. And we need to package our Kotlin application with that and root for running Linux applications. So it's not precisely more friendly. So I will introduce to you Android Things. So one of the things with Android is that now is being compatible with Kotlin, but it's using this interoperability that we have with Java. So I will tell you a little bit of benefits if we use Android Things. So the first thing is that we can create Android Things applications for embedded devices as Android applications. The next thing is they are handling all this information for connect us with third-party devices. Then, well, not only Google, a lot of cloud have IoT solutions for us. But they have a lot of libraries where we can make easy connections with that. That not only with the Google Cloud Platform, also to the Firebase platform. And in the Firebase platform, we can use the Firebase authentication too for make the part of security for our IoT devices. Then we have this. We can use the GPIOs, and we have the pools with modulation. So GPIOs is basically inputs and outputs for read sensors, and the pools with modulation is working for these things like motor of lights. In this case, we use that because we need to define the amount of grain that I will send to a motor. So for example, motors, if I send a high amount of grain, they will go faster, but if I send a low down, they will go slow. Then we have some peripheral for make a transaction of a communication of information, so I can have synchronous and asynchronous communication. This is something that is a little bit new, but one of the problems that we have with IoT projects is how I will make an actualization of my project in the IoT devices. So for example, with these systems that we have for detect Roya in coffee crops, so how I need to go to the farm and connect me directly to my devices for actualize anything. I cannot do that synchronization. So Google, for some devices that have access to internet, they are often, this is a kind of that Google Play but for Android Things. This is an extra one. If someone make an IoT project before, something really hard in IoT project is know the actual hour and date. But the people of Google make some dark magic, and we can find the date and hour in an easy way. But we have some restrictions. We can only use Android Things in these two microprocessors, the Raspberry Pi and NXP Pico. So this is a little diagram of how is working all this. So if you know or not, Android is an operating system based on the Linux kernel that 11 years ago was optimized for smartphone devices. But we need to take in mind that, for example, our smartphone devices that now have the same hardware resource that have our computers 10 years ago. But the cell phones 11 years ago has like 64 megabytes of RAM and maybe 5 gigas of memory. So they were like embedded devices. I think a Raspberry Pi have more resource than some cell phones now. 2 gigabytes of RAM, and you put an SD card of 1 terabyte, and you have 1 terabyte of room. So they, again, make an optimization of Android for can run this in embedded devices. So they have a hardware abstraction layer. Then we have the native libraries, because these continue using the Java native interface. So I can embed it or use the native libraries that we have in options. Then we have the API framework, the Google services if we want to use, and the Things support library for use all the components. And then we have our apps. So this is a code, as I mentioned to you. This is compatible with the Android native development kit that is compatible with the Java native interface. So I can decide if I will use it or not. So if I don't have any C library in my code, I can don't put this, that the default value is true. So that means that when I create my APK for my IoT device, we'll remove all these native libraries for make it smaller. If I want to use them, I will put this false, so will be a little bit bigger. So I will show you here a little bit an example how to create a Android Things application just for turn on and turn off a LED. So here I am creating the project. Here I am defining that I will use Kotlin. This is the minimum level API. So now the recommendation is use at least Android 8. I am putting the name of my project and my package name and when I will save it. And here I am creating a new activity. The activities basically are the main component in Android. I am not putting here the launch activity automatically on boot. I need to put that if I want a project turn on only when the device is turning on, because we don't have any human interaction. So here we need to add in our Gradle project, our library for Android things. And this is the manifest file when we have all the configuration of components in Android. This is basically the first one, but if we want that this be launched on boot, I need to add this second intent filter with these categories. So now this is a diagram of the hardware side. So I will use the 2 first GPUs in the Raspberry Pi in this case. And we are using a push button and a LED and some resistors and jumpers. So we will go to the activity code. This is the first import. So I will use the peripheral manager for open connections with my GPUs. And I am defining these 2 objects. This is for handle just the GPU. And this is for a callback for read what happened in the GPU or for send actions to the GPU. So we have here our home activity, and I am creating a tag for putting all my logs. Here in the button name exists a method that we can use for read the names of, depends on which card we are using, will be the names that have our GPUs. So I just put the dots. And this is purely of Kotlin. So Kotlin is a programming language that is trying to avoid any null pointer exception. So they try that we don't have anything with null. But I am established here a late init because in an activity, I have access in the start of the process when I have a method called the onCreate. But the onCreate almost happened after the construction of this class as an object. So I cannot initialize this. So when I don't make an initialization, you know Kotlin? Yes, so I don't need to explain that. Perfect, okay, I will avoid that. That was better, okay? I have here my onCreate method that happened after the construction, and I am creating here a manager. I am creating an instance of the peripheral manager, and now I am creating my button GPU. So with the manager, I am open my connection. I put the name of this pin. I will set in the direction. I am establishing that this is a GPU when I will read. So I will catch information for it. And then I want defining that is a event triggered event. So I will stay reading all the time using this callback. Now I have here defined the callback. So here I am overriding an on GPU edge method that receives the GPU. Right now, I am just logging that I press the button, and I am sending true. If I send false, the true means that I read now, but I will continue reading. If I put false, I read not, but I will not continue reading anymore during the duration of my project. So then we need to remember to close the connection when my activity dead. In this case, is like my project dead. So I will unregister my callback, and I will close my GPIO connection. Now we will talk about how I will send information to the LED. I will add these two variables. So I will have the name of the GPIO when I will send the information to the LED GPIO, and I will define a GPIO for my LED. Now I will add to the onCreate method. So again, with the manager, I will open the GPIO, and I will put the direction that is in a direction out, but with low power. So I only will turn a LED. And here I am going again to the callback, and now when it's pressed, so I will change the state of my LED. So I will send a false or true for turn on my LED. And finally, I need to remember to close my GPIO for LED 2. So now what happened with the security and connection in my IoT project? And I have something that is the cost of connectivity in IoT projects. And sometimes people don't think about that. It's like we connect our IoT project to Wi-Fi and everything will be okay. But this is not true. We will start, a Raspberry Pi maybe have a wireless thing, but usually we need to browse something, hardware, for add to our project, for have in production, for have access to Wi-Fi. But imagine the project in the middle of the jungle, in the farm, collecting information about crops. So there is no internet, right? So we need to exist some plans when you can put an SD card to every device. So you need to add that. So imagine that this device just have a cost of 50 cents. So if you have, for example, I have here numbers, 50 devices, you need to pay $50 for all your devices just for this hardware. If you have, for example, 500, you will pay 500. No, it's not 500. It's 2 and something like that. No, 250, right? Yeah. But this is just for have the hardware side. Then you need to pay monthly for the access to these chips have internet. So this could be more expensive. It could be a plan of $2. So if I will have 50 devices, I will pay $100. If I have 500 devices, I will pay $1,000. And I will put you a specific example. In Guatemala, the minimum salary for the city is $350. If you work in outside the city and you work in farms, the minimum salary there is $250. So if I say to the guy, you know, we will improve your production of coffee, we will detect faster ROIA with IoT devices, but you need to pay monthly $1,000 just for have this internet connection. What will say the guy? Fuck you, right? I will continue paying to that guy $250 for they go to each crop and verify if it had ROIA or not. So this is something that we need to take in advance. So I will show you some protocols that we can use in IoT projects. So for sure, at the beginning, we have Wi-Fi and Bluetooth projects. This just does work in all cases, just if you really will have access to Wi-Fi. So we can use maybe this in a smart home or smart buildings if I have this. With Bluetooth, can work, for example, with these wearables that have outlets. Usually it's for when I will have my IoT project. This is not my cell phone, it's this one. And I will put my cell phone near to the IoT device and transfer this information between the IoT device and my cell phone. So then we have this other one that is like 6LoWPAN. Basically, this is a protocol that like LANs technologies and can work if I have a wired, I think this is the name. So I go to buildings, I connect everything physically by cables for transport the information. Then we have Z-Waves. This is interesting because it's a low power radio frequency transfer between devices. Then we have Thread. Thread is interesting because it was not created precisely for make IoT projects, if not was a complement of Wi-Fi, but some people use it for make IoT. And Zigbee is something interesting in that I suggest to you go Google search about Zigbee because they have many protocols for may transfer information and they have also other products for IoT devices. But I have here something interesting. They have, for example, they permit transmit information but with a restricted area of 100 meters. That is not so bad. And it's more designed for home buildings. Then we have this cellular. This could be the most expensive protocol or transfer information in IoT, but it's designed for can transfer information up to 4 gigabytes. And in the data transfer. So it's expanded, but is when we will transfer high amounts of information, for example, pictures. And then we have Neul. This is an interesting one. I don't know, but you see here in Europe happen much that you go with your credit card and just put that near to the thing. This thing serves you in Neul for make the transaction. In that we have some applications when I can register my credit cards for make the payment and just I put close the cell phone to these devices. This works too with Neul. And in that I have in my cell phone, I'm sure that you have too. We can activate the Neul protocol or not in our cell phones for can use this kind of payment without touching. And then we have NFC. This is to near file communication, and we have this of 6-fold. And finally, we have LoRa, that is other kind of LAN communication. I will continue. How much time I have? Oh, wow. Okay, then I will talk to you about how I transfer. So this is our protocols for sending information to one point to other one. Then exists protocols to how I will send this information to one place to other one. So MQT basically is a replacement to the HTTP protocol. And what happened, this is basically for transfer information for my data to the place that I will send in. In that, something that happened is that usually, or in some cases, smart devices, my IoT devices, are not the one connecting themselves to the cloud for sending information. Then send this information to the middle guy, can be an IoT hub. This IoT hub will save all this information and then will transfer all the information in one moment to the cloud. So it's for reduced consumption too. So for that we use MQT. So with MQT, I am collecting all my information and then I am sending to the cloud. So what happened with MQT is that they are looking to be a more simple protocol. So I need to reduce the amount of money, information that I will send. And exists other thing that is about MQT, and is these people that is so pragmatic about what things we need to do and how we need to do them. So in IoT, we need to be a little bit more agnostic. And I mean about don't use, now we are trying to fight with some people for they stop to use XML and we use JSON. I don't know, but I know people that still continue using this. This is more heavy than a JSON. But what happened in IoT projects when sometimes I only have capacity for transfer 10 kilobytes or 100 kilobytes of information in every single transaction. So this have a cost. So what establishes MQT is that sometimes in IoT projects, we don't need to transfer this. So sometimes, for example, exists a project in United States that they introducing the air conditioner sensors of how people use the air conditioner. So which temperature in which moment. So they just have temperature and the schedule. So I need to create a JSON for send temperature and the hour? No. They just can send that separated by comma or put this thing vertical, because you know that what are these two values. So we need to create new ways to transfer that. The other thing that happened with HTTP and MQT is that MQT has less headers when we make the connections in both sides. And this is our two libraries, really good, in that both of them are from Eclipse Foundation, but Mosquito is really used for make MQT implementations for anything. They have for Arduino or for Raspberry Pi. And now what happened about security? So how I make for secure my IoT applications. For example, this is what the problem that have the light bulbs. They don't have any kind of security, so anyone can send information to the light bulbs, and anyone can hack this between the light bulbs to the cloud. So this is a little bit complicated because we don't have humans relationships here. So it's anyone introducing a username and a password. And I also cannot come and introduce a username and password and save it in the hardware, because anyone with access to this hardware have access to anything inside it. So in IoT devices, we don't have any trusted zone that anyone have access. So they use certifications. So I install a certification in my IoT device, and this will be basically my credentials for make an authentication process and authorization process inside a server. So we have here a MQT client that will be go to the authorization server with this certification and will obtain to a token for then make other kind of connections. So this is for have a fast explanation. And then, well, for create our backends for IoT projects. Usually IoT projects don't need more than one service, because I only will send a set of information. It's not like I will have a lot of options like happen in application or web applications. So we can use serverless. Do you know where is serverless? Yes, so I can skip that. They have face that don't know where is serverless. Function as a services. Yeah, no, this continue being with no. Why put this or, sorry. 3 minutes, okay. Okay, I will skip this, skip this, skip this. Okay, this is an example of what we have with microservices. So, you know, with monoliths, we have everything together. In microservices, we divide for small things with their own database in a pragmatic definition. Some people skip this part of have many databases and they have only one and are using microservices just for handle the deployment process. And this is an example of a monolith. When I have a host system, I have all my application, and inside my application, I have my operations. In serverless, the focus is that I am focused just in create my operations. The minimum logic that I have inside an application. So we have functions as unit of scale that we will run in ephemeral container. This of ephemeral is a cheap way that say that is elastic, and we can focus just on development. Sometimes I don't need to create a development environment. I just can put the code in the cloud, and that will run everything. So we don't have server management. This is of high availability and flexible scaling is because the cloud will create, we will run one function for attend every request that I have. So this is why this is elastic. So if I have 2 requests, I will have 2 times running my function for attend any one of these requests. And we only pay when the function is running. So they are event triggered. They are sleeping when anyone is requesting that. And this is what happened in IoT projects. I am not having all the time my devices sending information. Sometimes they send information every hour or every 5 hours, or just when something change in the sensors. So if I have sleeping that everything and just turn on when they send to that, maybe in there I will pay nothing for have a backend for my IoT devices. And I will skip these 2 because I think that I don't have more time. This is an architecture of serverless. I have here my functions. We have an API gateway when we receive all the endpoints, and this save the information in other part. This is a more complicated thing. Okay, this is other diagrams, and I will end this with, we don't need to create everything for IoT projects. Maybe I can explore and found a cloud solution for my IoT solutions. So we have in that other parts when we need to make a process of business intelligence, of artificial intelligence, for study all this information that I am catching for my sensors. So we have these cloud solutions. This is one that is called ThinkWorks 8 IoT platform. This is the Microsoft Azure suite for sure. This is the Google one. We have IBM Watson IoT for IoT solutions. This is, I don't remember of which one, AWS. We have Cisco too. We have Salesforce IoT Cloud. And this is, don't say here. I will, okay. This is the Oracle Cloud, and this is other one, and these slides are in this repository, and this is my fan page, and this is my tutor page, and now you can leave.
We don't have